Alright, this is Ms. Martinez, and in this video we are looking at solving rational equations. As a student, I'm looking for you to be able to solve rational equations and to solve equations that have distance and work in them, which create rational equations. So let's get started. Just a little review here. Solving equations. The first one, letter A, why don't you pause the video and try and do that on your own. Alrighty, this would be just a two-step solving. You would first subtract 7 from each side and then divide by 3, so x is 5. Now, problem B, there are different approaches you could take here, but I want to show you a nice approach that is actually going to be applicable in this lesson when we work with more complex rational equations. What you can do to get rid of the fraction is multiply the entire equation by that value. And when you do so, you would distribute that 3 to each term. That would give you 2y minus 18 equals 36. So you multiply every single term in the whole equation by 3. And now we're back to kind of simple two-step solving. You would add 18 and divide by 2. So y is 27. In problem C, you can take a very similar approach. But it's not going to be just 2 or just 5 that you multiply the whole equation by. You're going to multiply by the least common denominator. So let's think here. What is the least common multiple of 2 and 5? That is 10. And so you're going to multiply every single term in the equation by 10. 10 times 3/5 is 6, because 5 goes into 10 twice, so it's really 2 times 3. And then you'll have 5 times x minus 1, because 10 over 2 simplifies to 5. And 10 times 6 is 60. Using distribution, you would distribute the 5 to both the x and the negative 1. Combining like terms, that gives you 11x equals 65, and we can leave that as a fraction. It would just be 65 over 11. Now, with this idea, we're going to build on this concept in this lesson. We're going to solve, like you've been doing for some years now, but we're going to solve rational equations. So let's look at our first example. And I want us to try eliminating denominators. I know you could just multiply, do like cross multiplication and solve this, but I want to show you a different approach. The first thing you would do is multiply both sides by the least common denominator. That would be x times x plus 3. When you do that, you would be essentially multiplying the numerators of each of those terms by the LCD. And what that allows to happen is some simplification. Now what we're left with is 18x and 12 times x plus 3. I'm showing you on this simpler problem so that when we get to more complex ones, it's made more clear. Alright, so distribute, combine like terms, and divide. So x is 6. We can check this by plugging in, making sure that our value is correct. And it's really important to do this, especially when you're working with rational equations, because you want to make sure that when you substitute in, you do not create a false statement like dividing by 0. Here that doesn't happen, but we have 9 we have 18 over 9 plus 12 over 6. Both of those sides would be equal to 2, and that is a true statement. So this was done correctly, and we don't have any extraneous values. Another one here, a little bit more complex, but we're going to use the same approach. We're going to factor the denominators so that we can identify the least common denominator. That quadratic trinomial, when factored, would be x minus 4 and x plus 1. So the factors that need to be the least common denominator would be x minus 4 and x plus 1. That's what you would need in every denominator if you wanted to combine like terms. But we're going to multiply the entire equation here by that least common denominator. When we do that, you're going to see that there is a lot of simplification that goes on, and you'll no longer have anything in your denominator. Those terms cancel out, as do these and these, and lastly here. So the least common denominator was multiplied into the numerator of every term, and then we simplified. I'm trying to show you all the work here so there is no confusion. This is going to be continued here. Let's keep going. That means we would have x plus 1 times x plus 2 equals 30, because that's all that was left, and 4 times x minus 4. All right, we're going to do some distribution. When you FOIL the first, those two binomials, you'll have x squared plus 3x plus 2. And if you distribute the 4, it would be 4x minus 16. Now we're trying to solve. We're trying to solve for x. So we are going back to our studies in Algebra 2 of solving quadratics. That means we're going to move everything to one side and set it equal to 0. When you move all the terms to the left, the result is x squared minus x minus 12 equals 0. And now we can use the zero product property to solve. This is factored, and it would be x plus 3 and x minus 4, which tells me that x is -3 and 4. And like I mentioned in the last example, we need to check this to make sure that we won't have any extraneous answers. Extraneous answers are answers that, when you do the work, that is a result, but if you were to substitute it in, it would make the statement untrue. So let's work on that. We're going to check first the -3. So plugging in -3 into every position of x, the result would be 1 over 7 equals 30 over 14 plus 4 over -2. When you simplify, that would be 15/7 minus 2. And if you take away 2 sets of 7, you could think of it that way. From 15, that would be taking away 14. So that would, that would give you 1/7, equaling 1/7, and that is true. So that value of x being -3, is a true statement. But I want you to look at the first term and in the denominator. If you were to substitute in 4, it would be 4 minus 4, which is 0. And if you plugged it into the second term, it would also make that undefined. So -3 is the only solution, because if you plug in 4, the original expressions are undefined. So -3 is a solution, and 4 is what we call an extraneous solution. It is not a true answer. So that was solving, eliminating denominators to do so. I want to show you a case where we're working with work. Sounds kind of funny, but this is an application of physics here. So a large pool can be filled in 8 hours of continuous pumping using pump A. If a smaller pump B works with pump A, it takes only 6 hours to fill the pool. How long would it take to fill the pool using only pump B? All right, so what are we trying to find? I tried to highlight that for you. How long would it take to fill the pool using only pump B? We need to assign a variable because we don't know this time, but T is going to be the time for pump B to fill the pool alone. We're going to use that variable throughout this whole problem. Our next step will be to organize the information to create a table that will allow us to solve. So we're going to populate our table here for pump A, pump B, and the pumps working together. And we're going to list out the times and the rate of work. Now, rate of work is the jobs completed in an hour. So the jobs per hour. So let's get started here. Pump A takes 8 hours. Pump B, that's what we don't know. It is our variable T. Together they take 6 hours. So the rate of work would be, well, for pump A, you can complete one job in 8 hours. For pump B, you can complete one job in T hours. And together, you would complete one job in 6 hours. Okay, so now you're maybe thinking we're still stuck here. Well, let me enlighten you with a little tidbit here. The rates of working together is the sum of the individual rates. So this is going to allow us to write an equation. It would look like this. 1/8 plus 1 over T is equal to 1/6 because that's how much work is completed. So 1/8 is the work completed by pump A, 1T is the work completed by pump B, and together they do it in 1/6. One job in 6 hours. So we are going to solve this. You're going to multiply by the LCD so that you can eliminate your denominators. That'll be 3T plus 24 equals 4T. If you subtract 3T from each side, you find that T is 24. So pump B would fill the pool in 24 hours. All right, so that is an example of a work problem solved using rational expressions. And lastly, I want to show you a distance problem. Andrew drives the first third of the distance from Roanoke Rapids to Wilmington at an average rate of 52 miles per hour. What average speed must he maintain for the rest of the trip if he is to average 60 miles an hour over the course of the entire trip? All right, so we are trying to figure out the average speed he must maintain for the second part of the trip. That is what we need to represent with a variable. We'll let D be the entire distance because we're working with a distance problem and we don't know the distance. And R is his average speed for the second part of the trip. That is what we are concerned with finding. So let's organize our information. This is a distance problem. Distance is rate times time. So let's populate it. The rate for the first part is 52. We don't know the rate for the second part. That will be R. And the total, we want it to be 60. Now, I can't really do much with the time column, but I do know a little bit about distance. The first part of our trip is 1/3 of the total distance, which means the second part is 2/3 of the total distance, and our total distance is D. Now, rate times time gives me distance. which means that time is distance divided by the rate. So that would be d over 3 divided by 52. That'll give me the time. That would be d over 3 times 52. For the second part of the journey, it would be 2d divided by 3, or 2d over 3, that's my distance, divided by r, that's going to result in 2d over 3r. And lastly, my time for the total trip is just the total distance divided by my rate. Now, with this information, I am going to be able to figure out the rate that for that second part of the trip. And so what I'm going to use are the expressions for time. And here's what the equation will look like. You have the rates for the two will give you your total rate. The sum of the rates for the two parts will give you your total. I'm sorry, that's really the time. The sum of the times will give you your total time, but they are in terms of r, so this is going to be great. Notice that each of them has a d, and I don't really care to know the distance. I can go ahead and divide that out from all of the terms, and that'll give me the following. And that is completely fine. It's just so long as whatever I do to one side I do to the other, I'm following the laws of mathematics. All right, now I'm gonna solve this equation, and to do so I'm gonna multiply by my least common denominator, which means I'm gonna multiply them by 60 times 52r. And here's the result. You'll have 20r plus 2080 equals 52r. And then we'll subtract 20 from each side and divide by 32. So our rate that we would need for the rest of the trip is 65 miles an hour, which makes sense. You would have to exceed 60 if your first part of the trip you were going below 60, so that is a reasonable answer. All right, well, if you had any questions while watching these examples, please write them in the margins and we will go through them together. Thank you and have a good rest of your day.